I live in Richmond Heights, and we are surrounded by very cool architecture here. We have these houses that are decorated with bricks in a very beautiful fashion. They're always there. Every time I drive to work, I'm just surrounded by bricks everywhere. You go into one of these old houses, you find interior areas that have these red brick, and they could potentially be used for storing energy. It would be completely autonomous, off the grid in theory. This definitely was St. Louis trying to inspire us. What we do is that we look for inspiration in nature, and we try to find materials that are commonly regarded as waste or not useful chemical byproducts. We look at materials like the red pigment in bricks, which is known as rust or iron corrosion, as a possible source of feedstock for doing chemical synthesis. And so the idea of using minerals for making materials is the essence of chemistry. And we were successful. We were able to change the red pigment in a brick, which is rust, into this plastic that we make in the lab. We make a very thin film of a plastic. It is nanofibrillar. A nanofibrillar coating on a brick increases the surface area. So when you build a house and you put your red bricks in a house, if they have our coating, which is blue, they have a much larger surface area. We take two bricks and we put these two bricks together. And when you put them together, you can apply a potential to one, like a battery, and you can make it a positive potential, and you can apply a negative potential to the other. We were able to store electricity in that polymer, in that plastic, an organic semiconductor. The name of the device that we have made is called a supercapacitor. It can be recharged very fast, and it can deliver the energy very fast. It only takes 13 minutes for us to recharge a wall of 50 bricks. Those 50 bricks can be recharged in 13 minutes with a solar cell, and they can power an emergency light that consumes 3 watts of energy for 50 minutes, 50. The intensity of the light would continue to decrease over time because that's one of the properties of supercapacitors, but that can be modulated, that can be fixed with some type of converter, electrical converter. And that wall can be recharged within 13 minutes to its maximum capacity and continue to produce electricity and continue to power that light. Let's say if you had 1,000 bricks, you would power a laptop. 1,000 bricks would do it. I see the potential for incorporating sensors. The coatings that we have produced allow us to also make devices on bricks that can sense the temperature in the house, carbon dioxide in the house, gases in the house. When you're cleaning the bathroom, what chemicals are you using? What is the pH of the environment? Are you being exposed to chemicals? We have a couple of challenges. We need to increase the amount of energy that we can store in the bricks. But we're working on that, and we can definitely achieve the goals that we want within the next year. We know we're going to be able to increase this energy by 50%. This is a universal strategy. It works on any kind of brick. So if you have an old home, it can be retrofitted. If you have a new home, you can go and buy the bricks. The solar cell would provide the energy, and the bricks would store the energy. They last about 30 years. If 30 years later you want to come back and like recode it, or it should be accessible in case anything goes wrong and you need to go back and just look at the wires, what's going on with the wires. Other oxides of iron that you find in minerals are not just red. They can be yellow, green, black, or brown, and you can mix them so you can have bricks of different colors. This is not a commercial application yet. This is a proof of concept, but it demonstrates an intersection between architecture and chemistry, and brick had those properties. I knew that. What I did not expect is that it was going to be so good. I guess St. Louis was just telling us, go test the substrate. Then, once we got the substrate and we looked at the SDS of the substrate, so we looked at the safety data sheet. So where did this brick come from? We discovered that it came from St. Louis, the mud. We discovered that it's a company from here, and it was sold at a hardware store here, and we did the research here. What I would love is for this technology to stay here if it's possible. I would love for someone in St. Louis to be interested in keeping this technology here, because what we're encountering is a lot of interest from a lot of parts of the world in the technology. When you put all those things together, hindsight is 2020. Yeah, this definitely was St. Louis trying to inspire us.